Oh, yeah. Yeah, let me copy that. Okay, I'm handing in my homework. Now, I'm sure that all of you would have the experience of copying others' homework. Yes? No, I see shaking hands. No, you sure? It is an art to be a good copycat. But in life sciences, there are many copycats too. Cells, the basic unit of living things, copy the homework every minute and second. And today, I'm talking about cells copying the genetic materials, the DNA, during cell division, so that each cell carries one copy of DNA at the end. And copying the DNA is just like this, copying the homework. But normal cells in our body lose some DNA in a part called telomere every time they copy the DNA. And it's like they lost one letter in the first time, and they lost two in the second time, and after many times, the DNA is so much shortened that the cells cannot copy them anymore, and then they die. When too many cells in our body die, we die. Therefore, now we know that normal cells are poor copycats because they copy the homework incompletely. But cancer cells seem cleverer because they can retain the DNA completely without losing a word. And they are cleverer because they have a magic pen, telomerase. And telomerase writes a few more letters at the end of the DNA, see? And when the cancer cell loses one letter each time they copy the DNA, the original letters are still there. The original DNA of cancer cell is not shortened. Therefore, the cancer cells can make copies forever and ever without missing any letters. And they can multiply and multiply without dying. And that makes them immortal. But us sometimes die. Cancer cells, the clever copycats, use the magic pen, telomerase, to live longer. But we know that they are bad for our health. Can we learn from them? Can we use the magic pen put inside in our body to make us live longer? That probably doesn't work, and you may even get cancer. But scientists are working on brilliant ideas about how to use telomerase to make people live longer, but not getting cancer. It is not an easy task to do that, but if they succeed, we'll hopefully live 10 years longer. Of course, no matter how long we live, it is always more important to live happily, yes? I wish you all a happier and longer life. Thank you.
Hamid, what do you make of that?
I liked it, actually, Anthony. It was a clear explanation and to the point. You're a third-year student, right?
Yes.
And you're studying microbiology?
Biochemistry.
Biochemistry.
Yes.
And so what do you want to do in like 10 years' time? How do you see yourself?
10 years' time, it's a bit long, but I plan to, I'm applying a master degree.
Time runs.
Yeah, okay, I'm applying to master, and I want to contribute myself to research field, especially in biochemistry, yes.
Samandra?
I was very interested in, I thought it's a very good, clear analogy, and I was interested because I've heard of telomeres in relation to normal lifespan, and the idea that we could lengthen our lifespan if we could protect, but I didn't realise the cancer connection. So are you able to explain to me as a non-scientist very simply how people are looking at fighting cancer, but at the same time, how do you balance the fighting cancer against attacking the normal cells and the telomeres in our normal cells?
Yes, telomerase. Actually, cancer cells, they are telomerase, but normal cells don't have that, and that makes them, the cancer cell can grow inside our body out of control. But that is one of the point of healing from the cancer patients, and we can stop down the telomerase activity and try to slow down the telomerase activity in the cancer cells. So, and that is one of the point of the cancer patient treatment.
Anthony Cheung, thank you very much indeed for telling us about telomerase.